Okay, we look for the propositional equivalences. This one is continuation from the first chapter that you have learned. Okay, and then so far you have learned the proposition, proposition in chapter 1.1. Okay, in propositional logic, logical equivalent is defined in terms of propositional variables. Okay, two compound proposition are logically equivalent if they have same truth values for all possible truth values of the propositional variable that they contain. This one is a general statement of the propositional equivalences. Okay, and then the terminology, tautology is proposition which is always be true. Okay, we have first tautology. Tautology. Okay, and then contradiction. Contradict is a proposition that is always false. Okay, we have a variable, one variable. For example, the 2 power of 1 equivalent to 2. Okay, okay, this one is contradiction. Contradict. Contradict, which means you need to negate the values. Okay, then contingency is that I explained before is the proposition that is neither a tautology or a contradiction. Therefore, we have P or Q implies negate R. Okay. Okay, we have first tautology, second is contradiction, thirdly is contingency lah. Okay. Okay, so far do you have any question? Is it okay? Yeah. Okay, for this one, we have P or negate P. This one is always true is tautology because we have the uh, statement 1 and statement 2 true. And then when we have always false, false and false, we name it as a contradiction. And then to have the truth table, you need to have 2 power of 1. Okay, equivalent to 2. One variable, P only. Okay, and then we have 2, 1 and 2. Okay, and then we have logical equivalences. Two proposition P and Q are logically equivalent if they have the same truth value in all possible cases. Okay, two proposition P and Q are logically equivalent if P biconditional, P biconditional Q is a tautology, or we can say notation. Notation either one. You can have like this, okay, or three line is equivalent. It's just the notation. Notation. Okay. Okay, determining the logical equivalence. First of all, you need to have the truth values. Okay, and then show that the negate P or Q and P negate P and negate Q are logically equivalent. Not a very efficient method. Why? Why? Not very efficient. Okay, because of you need to draw the truth table first, and then you need to show and depict the equivalences for every hypothesis. Okay, for the solution, we develop a series of equivalences. This one is based on the hypothesis. Okay, and then we the important equivalences. Okay, propositional equivalence. We have number one, true, P and T. Okay, equivalence to P. This one, the name is to identify domination, idempotent, and double negation. One, two, three, four. Okay, I explain this one. For the identity. For the identity, you need to know the identity. Identity law in the discrete math uh, is the law to identify the state that each thing is identical with itself. Okay, we have P and uh, T is truth equivalent to P lah. And then P or false equivalent to P is the identity. It is first is state that each thing is identical with itself. Okay, either true or false. Okay, the law of identity state that if a statement has been determined to be true, then the statement is true lah. Okay, if the statement has been determined to be false, and then the statement is false lah. For example, if I make a statement that it is snowing and it is the truth, then the statement must be true lah. This one is identity. Is it okay for identity? Okay, alright. And then secondly is also we call it as identity lah. Okay. And then secondly is domination. Domination. Okay, for the domination law. Okay. Okay, we have here P or T and P and false. Okay, false and x equivalent to f. If the first thing in an expression is false, then it doesn't matter whether the second thing is true or false. And the n expression is going to false either way lah. Okay, if false, if the first thing in all expression, is true, then it doesn't matter whether the second thing is true or false. The all expression is going to be true either way. Okay, please remember that one. If the first thing in the all expression is true, we can see here is the true. First thing is true. Okay. Okay, and then we can say that uh, okay, we can say that or we can say the expression is going to be true either way. Going to true either way. Okay, same goes to n. Okay, if the first thing and expression is false, and it doesn't matter whether the second thing is true or false, the n expression is going to false anyway. This one going to false anyway. Okay, please get into the notes or n. Okay, and then for idempotent laws, we have or if the first thing in all expression is false, okay, The value of the expression will be true if x is true or false if x is false. In other hand, the all expression will have the same truth value as x does. Okay, we have or. Okay, idem important. Same goes to n lah. If the first thing in the n expression is true, then the value of n expression will be true if x is true. Okay, here if p is true. Okay, if p is true or false if p is false. In other words, the n expression will have the same truth value as p does. Okay, we have a negation p and negation p again. We have the same values. Okay, we have negation p lah. Also goes with the negate p. Okay, same goes here. Same output. Output is the same. Equivalent. Equivalent here, or you can have this one. Equivalent symbol. Is it okay? Is it okay, guys? Okay. Okay. If you have any doubt or problem, you can ask me. Okay, and then we have a double negation. Double negation. In propositional logic, double negation is the theorem that describe or state that if the statement is true, then it is not the case of that the statement is not true. Okay, we have the double negation. Okay, is negative. Negative imply negative is a positive. Implies P lah. Okay. Okay. Here we can see here is a negative. Negative imply negative is positive. But if we go negative, negative is a positive, and then we implies again negative is a negative x. It's double negation law lah. We have 1, 2, 3, 4 lah. Identity, domination. Okay, in the important is same equivalent to the output lah. Okay, and then we have a double negation. Okay, simple. Okay, this one is important equivalences. We have another one, commutative, okay, associative, distributive, and De Morgan law. Okay, we have another four. 1, 2, 3, 4. Okay. Okay. What is commutative? Commutative. Commutative. If you see on the screen, we have P or Q or negate P. We just change the Q and P. Is given the P negate P or negate P or Q lah. This one is commutative law. Commutative law you need to change. Okay. In mathematics, commutative is changing the order of the operations and does not change the result. Okay, please bear in mind this one is not change the output. Output. Okay. It is fundamental properties of many binary of many properties, equivalent properties uh, that and many mathematical proof lah. Okay, commutative law says we can swap numbers, we can swap the proposition and still get the same output. We just swap. This one we just swap, and then the output will be same lah. Okay, do you have any questions so far? Is it okay? Okay. Okay, and then number two, we can have associative law. Basically, associative law in maths. Associative law in mathematics, either two law relating it to the number of operation of additional or multiplication. Okay, we can have associative P or Q, and R is equivalent to P, and Q or R is the same associative. Okay? Okay, for example, we have 5 multiplied by 4 multiplied by 2 is the same, goes to 5 multiplied by 4 multiplied by 2 lah. Okay, for example, okay, cukup kertas kena buat satu lagi. Okay, this one associative associative example, we have 5. Okay, the one is 5 equivalent to 20. Okay, is same This one is associative Okay, and then we have the distributive. Okay, second one is clear associative. First one is we want to commutative is swap swap. Second one we just coordinate the position Ada soalan ke? Do you have any question? Boring ke kelas saya ni? Boring Eh, terpaksa lah kamu terpaksa ambil, nak buat macam mana? Eh, saya pun kalau boleh tak nak ngajar kamu, tapi dah kamu terpaksa ambil. Saya pun terpaksa ngajar. Okay, and then we have distributive in mathematics. The law related to the operation of multiplication and addition is stated as A column P plus C equivalent to AB plus AC. Okay, we just open up the column for this one P we combining the P into the Q and then P or Q, okay, because we combining P here, same goes here, okay, and then the here we put here lah N P or Q and P or R, okay, we just open up the bracket. Okay, this one is distributive. You open up the uh, the factors, the hypothesis. Okay, and then second one is also same. P and Q or R. Okay, okay, this one also same. You put P into the column. Okay, and then P and Q. Okay, and or P and R. Okay, but the distributive, associative, and commutative, the output is the same, still the same. Okay, and then the last one, is the De Morgan law. Okay, for the De Morgan law, you need to understand that also open up the bracket. Open up the bracket. You can see here negate P and Q. We same is same as the negate P or negate Q lah. Okay, for example, we have minus x plus y, and then this one equivalent to minus x and minus y lah. Okay, we open up we eliminate the bracket. This one we eliminate the bracket. This one we put the proposition into the bracket. Okay. Okay. This one is the distributive and De Morgan. Some of the student might be confusing. Distributive, you put the values inside the column. Okay, and then for the De Morgan, you eliminate the column. Okay, open. Yes. Yeah. Uh, mhm. Simbol apa? Bracket tutup. Ah, ya, ya, dia punya compound statement tu akan berubah lah. Sebab dia punya output dia when you go by the truth table, output dia kena sama lah. The output must be same. De Morgan law is the theorem that complement the product of all terms is equal to the sum of the complement of each term lah. Okay, bila kamu buka, for example, minus x plus y, when you open up the bracket, you want to eliminate negative x, then negative y. The output must be same. Output dia kena sama. Kena sama. Likewise, the complement of sum of all term is equal to the product of complement of each term. Okay. Boleh? Siapa nama tadi? Hamdan. Okay, simple je. Jangan complicated sangat. Okay. Okay, and then, okay, this one is the identity. We have true values. Okay, is equivalent to P. Okay, and then the second one is false. P or F equivalent to P is identity. Okay, we have 1 and 2. Okay, and then P and T is equivalent to T, true. Okay, P and F is equivalent to F. This one is domination. This one is identity. Okay. Okay, so far is it okay? Identity and domination. Okay, for the identity, is the properties of one says that the number of multiplied by one keep it identity. Identity must be same. Okay, for example here, if you can see, this one is true. True is keep the identity 1 and 2 same for the premise. Also goes to F, false. Okay, same for the identity. It's called the identity. The output is same. Okay, the reason the number stays the same because they multiply by one mean we have one copy of the number. Okay. Okay, later we see this one identity. What is identity for the set is same for the union and intersection. Okay, and then we have domination. Okay, P or T equivalent to true. The first thing an expression is false, then it doesn't matter whether the second thing is true or false. The end expression is going to be false anyway. Okay, the first thing expression is goes to the first expression lah. First expression kalau if it is true, it's going to equivalent to true lah. Okay, same goes to false. If the first statement is false, second statement is doesn't matter lah. Is going to be false. Okay, this one identity and domination. It's just a terms. It's just a terms. Okay, and then important equivalences. We have the absorption and negation. Absorption. We have here same P and P is same, and then we have the repetitive variable. Okay, here is the same and repetitive. Again, equivalent same to P lah. This one is the absorption. We absorb the values. Okay, the absorption law or absorption identity is identity linking in a pair of binary operation lah. Two binary operation are said to be connected by the absorption law. Okay, if you have the same, let's say here we have P is the same, then we absorb all the values same to the uh, variable output. Okay, and then the second one is negation. And negate we just okay put the negation. Okay, this one is true. The second one is false because we negate the P and or P or lah. Okay, this one is negation and absorption. And then this one is equivalent because this one is the distributive law is the equivalent P or Q and R is equivalent to P or Q and P or R. Okay, because we open up we put here in the open bracket lah, P and Q, and then we put P here lah. Okay. Okay, this one is distributive. Distributive mean the output must be same. Same output. Okay, same goes to here lah. We have or and okay. Okay, P and Q and R. Okay, when we have the distributive, we have P or Q and we put here and then O. Okay, O here we put here and or here. Okay, O O N. Okay, and then number two, P and Q or R. Okay, and then we put O here and okay, and then the last one, P O N O. Okay, and then we put P or Q and R. Okay, this one is third one. Okay. Okay, so far, do you have any question? This one is just distributive, distributive law. Okay, for example, you have A bracket B plus C is equivalent to AB plus AC lah. Same goes here, P or Q and R. When you open up the bracket, uh, you put P or Q and P or R is the same. Is distributive. Distributive means you just change the position. Okay. Okay. It is different with the De Morgan law. De Morgan law, you want to open up the column, open column and end column. Okay. Here we have a negate P is differently, or when you open up, the output will be n. Okay, same goes here. Negative x. Okay, negative x is going to negative y. Okay, same goes here. Negate p or negate q. We open up a negate p and okay, because here is De Morgan law is we change the compound statement. Okay, and then we have a double negation. X plus 1 is equivalent to negation, double negation. Goes same x plus 1. Same goes here. Keep negate P and negate Q. Okay, we all. Okay, equivalent to negate bracket, negate P and Q. Okay, we open up the here is double negation. Okay, this one is a single negation. Okay, this one is De Morgan law. Okay, for the double negation and so on. Okay, and then again, this one is distributive and absorption. Absorption, you need to absorb the repeated values or variable. Okay, for this one is absorption because you want to absorb P or P and Q. The final output will be P lah. Same. Okay, and then this one distributive. Distributive mean you need to group the the uh, for the uh, hypothesis. Okay, for example, we have P and Q. We combine, combine and okay, we put here N P or R. Okay, okay, distributive is the variable itself. Okay, this one is another example. We have true value is the domination. We want to dominate. This one is a tautology. Okay, we have the series of equivalences. We have commutative, negation, and domination. Name of the equivalences. Okay, commutative, negation, and domination. Okay. Okay, this one I think we continue next week. Okay, please see my uh, YouTube YouTube channel. I will explain. Okay, I will explain after this for the chapter 1.2 or chapter 2 lah. Okay, so far do you have any question? Is it okay? I know. Or you said no?